So section 2.6 is related rates. The textbook says related rates is a case of a chain rule application, which definitely it is the chain rule. And it says it's to find rates of change for two or more related variables. So let's write that down. Two or more related variables. That are changing with respect to time. Now, actually I have not looked up yet at this point definitions about related rates. It could be that it's one of these technical things that related rates really do have to be with respect to time. But the notion here, it doesn't have to be time. It could be, things change based on dollars, right? If you're a company and you're deciding how much to invest, you could have various things that would have, their rates of change of either quantities or dollars themselves, or areas, as far as land or something like that, or efficiencies as you spend more dollars. So, this idea that it has to be time is a bit limited. But at any rate, in your text, they just look at time, and so their first example is a conical, I guess, water container or liquid container, and so you have liquid at some height. That height is h, and at that height you would have some radius r, and the volume is equal to, for a cone, pi over 3 r squared h. Now, it's interesting that there's a nice theorem that says if you have something where you have a base and then from all sides you come up to a point, the volume of that is 1/3 of the volume of the same type of container, same sort of base that had vertical sides. So notice that if I had a cylinder like this, then the height is h, and the cross sectional area here, the base area, is pi r squared, right? So the volume on that would be pi r squared h, base area times height, and then the volume of a cone is 1/3 that. So it's, that's an interesting thing. But if you take any sort of base, so if I had a rectangular prism like this, and here's a height, I guess, and a width and a length maybe, or something along those lines, right? My volume is length times width times height. But if at that height instead I did something more like a pyramid, then in that case, if that's still L and W and we still have the height, then in that case the volume would be my height times width times length over 3. So it's just, kind of an interesting thing that it's always that 1/3, and so 2/3 is missing. But at any rate, so we have volume is pi over 3r squared h. Well, if r is r of t, a function of t, and h is h of t, some other function of t, then our volume, v, is also some function of t. And so then I could talk about dv dt. Well, since these are just a couple of functions, then I have pi over 3 times the derivative of r squared h with respect to t. And now that's a product, and so that is pi over 3 times the derivative of r squared with respect to t, and then times h, plus r squared times the derivative of h with respect to t. And so just had a colleague stop in. He was complaining about something. And then he noticed I was doing a video. So anyway, so we have our product rule there. And this part's done because I have r squared and dh dt. But this part is not done because you see I have r of t quantity squared, so I need a chain rule on that. And so this is pi over 3, and the outside part, right, we have 2r, but then we have dr dt and all times h plus r squared dh dt. And so if I kind of clean things up a little bit so they look a bit better, I have my pi over 3 times 2rh dr dt plus r squared dh dt. Now, and actually if I knew more about the cone, I could have written either r in terms of h or h in terms of r, but I would have to know more about the cone. But in this case, if I don't know about the cone, but somebody just tells me, at if somebody said at, no, I have an equal sign there, at r equals 3 and h equals 4, assuming that that would make sense for that cone, then dr dt is equal to 2 and dh dt is equal to 1, if that were to make any sense whatsoever. Then in that case I could tell you that dv dt at, and here there's, when you write dv dt, there's not a really good way to write at a particular time. Let's see, at oh, and I never gave the time here. I don't actually need it to figure anything out, but we'll say this is for maybe t equal 5 or something like that. To actually put that in, The best notation I have would be, sorry about that, every once in a while I get the pen too close to the bottom down there and it scrolls up. We'll use this line thing later in the course. So this is dv/dt at t equals 5. That is not a standard notation for something like this. I don't know that you'll find it in any books, but it is a standard notation for integrals when we start doing that, and so it's not like it's heretical or anything to write that. And so, you know, I could plug all these things in. I've got my pi over 3, 2 times r was 3, h was 4, dr dt was 2, r was 3, so that's 3 squared, dh dt was 1, and so I would have my pi over 3 times, what do we have, 16 times 3 is 48, plus 9, so we get, is that 57? Yeah, so 57 pi over 3, but 57 divided by 3 is 19 pi. You know, so we get the volume, the rate of change of the volume as 19 pi cubic units per time unit, whatever our cubic units were in our time unit. So, you know, that's the idea with related rates, and you know, that's really all there is to it. There are a lot of sort of strange problems with all these that people come up with, and we'll look at a couple of them. But that's just the idea. Is we have it in, you know, we have the related rates in this section, partly because, you know, we tend to say, like in this case, right, we had volume was a function of t, but to actually get it, we had volume was a function of r and h. Okay, but they were functions of t, so this was v was a function of r of t and h of t, and so now we see a composition thing going on here, because we have r of t and then v of r, and same with h, and so you know, that's where the chain rule part comes in. But had this been like area length times width, we would have never really thought much about the chain rule. We would have really just thought about the product rule with it. But this is why it is in here after the chain rule, because really, you know, we're doing the chain rule each time, whether we really think about it or not. Okay, so there's our intro to related rates.